Okay, so we're working on the Zenith 5S119, and we have a large electrolytic here. And this is actually going to be replaced with this little guy here, believe it or not. Technology, huh? Things have really changed over the years and gotten far more compact. But look how beautiful this is. I mean, we don't want to throw this away. And I don't really want to just tack this on the bottom, cluttering up the chassis even more. And we want to keep this looking as original as possible. So, you know, I've learned from other YouTubers, etc., how to actually rebuild these old aluminum electrolytics. So, and you know, in doing so, I've kind of learned some of my own techniques as well. This one I started with just the X-Acto knife, and I worked my way around this edge here of this. I don't know what it is. It's some type of wood or plastic. I don't know, masonite perhaps, or some sort. And all around the edge, because you don't want to start hacking at the aluminum right away and cutting it. It's really not necessary. This aluminum is very, very soft and pliable. So I just took a little bit of the, I don't know if you can see that, sort of the top surface all the way around with the blade, just working my way around. And that allowed me then to get my, just a small blade driver under there and start lifting the lip of the aluminum. You can see here, this part was actually folded over, holding this in place. So I worked my way around, just straightening it out, and that's where we're at now. So you can see the leads here behind, and then the inside is sort of a wrapper of, I believe it's foil with paper as an insulator, and a type of electrolytic liquid mixture that they used. And that's sort of all wrapped around in there, sort of like, I don't know, a confectionery, strange confection pastry of electronic pastry. And I guess if you took it out and unrolled it, which I've done before, you know, it goes on for quite a while. But it's held together in place, I believe, with some type of a tar. So what we're going to do now is we're actually going to use my heat gun, and we're going to warm this up a bit. I apologize for my poor video skills here. It's actually the first video I've made documenting this type of thing. So here we go. We're going to work our way around. I'm not worried about damaging anything inside. We're really going to just pull the guts out of this thing, throw it away, and we're just going to leave clean out the aluminum shell. But if we heat this up, it's going to go much more easily. Alright, so I'm going to do this sort of off video here and work this out, and I'll be right back. Okay, so I've heated it up. It really didn't take much at all. Just about, I probably had the iron on there longer than I needed to. The heating blower, I should say. And it's ready to come out. The can is quite hot right now, so we're just gonna grab it and pull it out. And hopefully it hasn't, I should be using a tripod for this. There we go. So there's a sort of Tootsie Roll in there, and boy, this one came out very easily. Some of the others I've done have been really left quite a mess in there, but this really doesn't require any work at all. At this point, we could just snip those leads there, add the capacitor to it, and put it back together again. So far this has been a delight to work on. Let me just show you some of the markings here on the electrolytic. This is an 8.8 microfarad, and what does that say there? 475 working volts. And in the circuit, they're actually using this as a 16 microfarad. So you're on the chassis where these were soldered, the two positive terminals were soldered together, and that created a 16 microfarad capacitor. When you wire capacitors in parallel that way, the capacitance doubles. I believe that the voltage doubles as well. So the 475 would have been doubled as well. All right, I'm going to start taking this apart, and I'll be right back. So we've just snipped the wires here in the back, and this is the new capacitor. These are electrolytic, so these are polarized. Obviously, there is a positive or negative. That's denoted here on the old electrolytic as well. The paint is worn, but you can see the two red for positive and the black for negative. This capacitor is actually not one capacitor. These cans are usually, I think probably always, I'm not sure exactly, but it's actually two capacitors in one. These cans are usually, as I said, multi-caps, and two is a little unusual, I think, or, you know, fairly, a little bit less common. Usually I've seen there's three capacitors inside, and so you would have an additional lead coming out of the bottom here. You know, in the circuit, this is being used again as one capacitor because they're joining the two positive leads in series, making the 8 in here an actual 16. So I'm not going to bother reforming this with two capacitors, two 8s. I'm just going to go ahead. I'm going to use this this 16. One other interesting thing is that with capacitors, if you do the way you join capacitors, whether in series or parallel, affects the actual capacitance. This is kind of a neat trick. You know, if you need to make a replacement in a capacitor, but you don't have the correct value, you can join capacitors together to get the, you know, using whatever you have on hand to get as close as possible to your desired capacitance. So I mentioned that when you join capacitors in parallel, which is done on this particular circuit, the two 8s become a 16. But interesting, if you join the capacitors in series, the capacitance is actually reduced. So if you have two 8s, for example, in series, you would actually end up with a 4 microfarad capacitor. So kind of interesting. All right, so I'm going to go ahead and I'm going to start putting this together. This capacitor is just going to be attached to these leads here. So we'll just put it back together and put it back in the circuit. I wasn't anticipating on using this plate, so I actually just snipped the soldering joints on the chassis, and I wish I had instead desoldered them, because what I did is I cut these down to nothing. So I've got to figure out a way of dressing these, because I like this, and it came out very cleanly, so I want to use it. So so just keep that in mind when you're working on your own. You may want to actually reuse the plate if you can get it out completely. So we'll see what I can do about that. I might just leave them in there and maybe put a small hole next to it and extend the leads of the capacitor out. So, you know, we have the look of it, but we'll make do the best we can. The other thing I noticed, which works really well, is I was thinking perhaps I might need to stuff this can with some way to support this, but no, it actually drops in really nicely. The lip here is holding this in place, so you can see that there's a ridge, so this will not fall back in. So once we have it all together, it's really quite simple. Drop it in, and we're going to fold in these this lip again on the aluminum, and we'll have ourselves a rebuilt electrolytic capacitor. Okay, again, sorry, this is the first time I'm making a video of any type of electrical restoration, so if I continue doing this, hopefully I'll improve, and this will be a learning experience for me. All right, hang in there. Thank you. Okay, so I'm looking at the a little more about this bottom part of the electrolytic and how I'm going to connect these leads of the new capacitor. And you can see the leads are rather short, and this being an axial, I'm not sure it's going to fit. Let's see here. Will it fit if I put it in this way? These electrolytics come in two fashions: the electrolytic and the axial and the radial. The radials will have both leads coming out of one end. This is an axial, and we'll have a lead coming out of one end and another lead coming out of the other end. And you know, they're the same. They're the same type of capacitor. It's just you buy the leads you need depending on what usage you're using. Some layouts will work better if you're working with the PC board. Obviously, you're going to want the radial. These old ones, the old radios, the axials work really well because you're usually jumping from place to place. But let's see, will this fit in this way? No, it's going to be too tight. That's not going to work. So it's going to have to stand up this way inside the can. And so we're going to try to use these existing leads here that I cut off of the old capacitor. And it's kind of fragile. I was going to attempt at stripping them. And I think I want to keep as much of the metal as possible. But instead of dealing with cutting a little bit off, trying to figure it out, I think I really want to just strip these down to the bare wire, and then I could add some heat shrink tubing around the leads of both the wire and the capacitor as needed. But I think if I start just pulling these out, I'm going to start losing some thread. So I've never tried this before, so I'm just going to make an attempt now to heat up the insulation here. It's a type of plastic. And see if that doesn't help me to slip it off. I may make a mess, or it may work brilliantly. I'm going to give that a try now off camera, and I'll let you know how it goes. Okay, yeah, that seems to work very well. I've heated this one up, and you can see it's pulling off really nicely. I don't have a tripod set up, so I really need my other hand. So I just wanted to show you that heating it up, boy oh boy, that just came right out. So that's a good option if you ever want to try to get some insulation, rubber insulation, off of an old wire, and you're afraid to just put the wire cutters on it and strip it, etc., and lose your threads. So I'm going to continue with this. Seems to be working, and we'll be right back. And here we have the leads, mostly bare wire here. Still a little bit of the residue of the insulation, the rubber there. So I'm going to take a little bit of light sandpaper now, try to clean that off, prepare these wires for soldering to the capacitor terminals. And let me get working on that off camera, and we'll be back. I'm still going to have the issue here. I've got to figure out something here, how to fix the problem I created when I snipped those leads too low. We may have to solder, clean these off, and sand them down a bit, prepare the surface, and maybe solder a lug to each one here. So let me see what I can do about that. Okay, we'll be back. All those wires are cleaned up now, sanded off, just a little bit of I don't know, light grit sandpaper. This says 220 fine. That seemed to work fine. I'm no expert when it comes to refinishing, that's for sure. So I had some of this lying around. I wouldn't, all I can say is I wouldn't, if you're trying to clean wiring, etc. with sandpaper, obviously you want to use something that's very fine. You don't want to disrupt the braid at all in the wiring. It's fairly delicate, especially this older stuff. So what I've done is I've wound the two positive leads together here, and I'm going to now attach the positive leads of the electrolytic here, and we'll solder that together. I don't think we actually really need any insulation on the wiring, and when it's all put together, I think you'll see why. We could use a little heat shrink tubing, but I think it's just going to get in the way. It's not going to be necessary for this. But again, electrolytics are polarized, so it's very important that you get polarity correct. On the old one here, it's denoted with the two red for positive, so I've put those together. Again, we're going to make this just one capacitor, not a dual capacitor. On the electrolytics, I'm sure most of you are well aware of this, but the band here points, the arrow points to the negative side, okay? And the other side is the positive. Very, very important that this is done correctly. All right, I'm going to start putting together the positive side here, and I'll be back to show you what that looks like. And before we actually begin the soldering, I could, just wrap the lead from the new capacitor around this wiring here, and then try to solder it. But I think we're going to have very much better luck if we tin the leads a bit, particularly on this portion here with the exposed braid. And that just means we're going to apply a little bit of solder here to the lead. And that'll just make it much easier when we actually do apply the heat with the two, with the capacitor leads joined. It'll be a little quicker for them to solidify, and there'll be less dwell time on the capacitor. And the less time you have heat on a semiconductor, obviously the better. So I'm going to go ahead and do that. Okay, there's the leads twisted together and tinned. So as I was doing this, the solder wasn't taking all that well. One of the problems is that the tip I'm using on right now on my iron is I was doing some more low voltage work and doing a PC board, so I have the thinner tip on here. But so with the larger tip, I'm going to switch to that soon once this cools off. With the larger tip, it would have helped as it would have conducted more heat to the strip here, and that's it's a fair amount of metal there, but it acts kind of as a heat sink. So the more metal you have, the harder it is to heat up the surface. So I'm going to switch to that. Unfortunately, when this Heiko here, I could really crank up the heat. This says adjustable heat setting, so I just cranked it up to the highest setting, 899. So that helped quite a bit, and that put more heat on the smaller tip. Not as much heat as it would have with the larger tip, such as, let's see, well, something like this. That's a little too big for this what we're doing right now, but that's an example of how big they can go. And let's see, we've got this guy. This I like to do when I'm working on old radios. That's about right. And it has a little bit of a, let's see if I can get this to focus. A little bit of the sort of a wedge shape, which is really quite nice. But what really made the difference here in getting the solder to bond was the use of a bit of a flux. The flux actually is part of the core of most solders. This solder, for example, here does have flux in it. And what that does is, I think it has sort of acidic properties. I'm not sure exactly, but it helps to break down any oxidation or surface contaminants on the metal, and then it helps the solder to flow more. But many times the flux that's including within the core of the solder isn't quite enough to do the job. So something like this, what you can do is you can actually apply a bit of soldering flux yourself here. So I just dab that on the wiring with the Q-tip. And yeah, that helped. The combination of the bigger tip, the increased heat, and the flux, and got a pretty good bit of solder flow going there. Okay. So here I have the positive lead of the capacitor attached to the positive leads of the little the bottom board of the old electrolytic can. So maybe I'm overthinking this a little bit, but I was really trying to think of a way. I want this new capacitor to stand up sort of in line, parallel with the can. I really try to think about what's the best way to wrap this, and I've determined that what I do is I cut a little bit of the lead off this capacitor, and I've just attached it. I bent it over, and then I cinched it down with the pliers right at this point here. So what I'm going to do now is I'm going to start wrapping this electrolytic around, and hopefully we'll have a nice good connection here, and then we can solder it together. You know, when you're soldering things together, you know, the more solid the connection, the better. You know, I could attempt to sort of just, you know, solder the lead in line with this, maybe do a quick wrap, but obviously if we can really wrap it around there and tighten it together, this is going to hold and have much better connection. Once this guy is put back together and soldered in, we don't want to have a problem here and have to take it apart again. So let's make sure that we put this together as tightly as possible and have the best connections we possibly can. Okay, so let me do that now, and I'll show you what it looks like. So we have the leads wrapped around nicely, and we'll solder that together. And once that's done, that'll allow us to straighten this capacitor out. So again, it's in line parallel with the can back there. And then we'll connect this negative lead of the capacitor to the negative lead coming out of this little, I don't know, I guess I call it a terminal board on the outer plate of the can. All right, let's put that together and I'll show you what it looks like. Okay, yeah, it looks good. Made a nice connection there. I added a little bit of a little more flux to that before I soldered it. Everything came together really quite nicely. So now we're going to sort of, this will straighten out in the can, and hopefully we'll have enough wire here to meet that around. Okay, so we're getting there. Let me put the negative leads together, and we'll be back with that. Okay, so I've joined the negative side of the electrolytic capacitor to the negative side of the terminal board here, and just didn't have as much in the way of lead length to get quite as good as a wrap as the other side, but yeah, I've wrapped it together pretty well, and that's going to be fine. I'm going to add a little flux to that. Solder that together, bend it over, and we'll be back. Okay, here we have it. Looks good. That should fit right in the can nicely. I don't think it's necessary, but I think I'm going to add a little dressing to this negative lead here, so it doesn't go up against the can of the electrolytic. I'm not sure it's such a big deal, because generally the negative leads are often grounded anyway to the chassis. I don't have the chassis in front of me right now, or the schematic to see if that's the case in this one, but just in the event that it's not grounded in that way, and you know, inside this capacitor, I didn't see this was connected in any way to the outer can, so I'm just going to do my best here to cover this up here, so when we put it together, it doesn't connect to the can in any way. I don't think aluminum is that great of a conductor anyway, but let's do that just to be on the safe side. So we put this together. We don't have any connections where we don't want them. Okay. I didn't actually have any heat shrink tubing that was large enough to go around that capacitor, so I just wrapped it up with a little bit of electrical tape. It kind of holds it together nicely. So here you can see how it's ready to go inside the can as such, and in the background we have the old capacitor. So again, this is now replacing this. This is now one 16 microfarad capacitor. whereas this was 2 8s being used together as to create an equivalent of one 16 microfarad capacitor. Okay, so I'm going to put this together again, and then, well, let me see, I might, before I put it together, start thinking about what to do with these leads, because once we get it together and I pop it into the chassis, we're going to need to connect those, the wiring and circuit to this, and this, what we have here is not ideal at all, so let me think about that. Okay, here we have our flux and our capacitor, our flux capacitor. Boy, I was listening back to some of the footage I was just took. Again, this is my first video, and there were a lot of ums, and I'm going to do my best to try to take care of the situation, because I'll tell you what, just listening to it back, I was annoying myself with a number of ums. It's interesting, I watched quite a few, oh, actually it's not the ums, I think it's the ahs. I just did it, okay. There I go again. I watch a lot of YouTubers, and I notice, different people have different styles of speaking. Some people are from the South, and, they pronounce things a little differently than I would here in the Northeast. One of my pet peeves is heith. I don't believe heith is a word. In the South, it's fairly common that people will say the word heith instead of height. And it just drives me nuts when I hear it. So, but I'm having a little empathy now for other people, because listening to myself, I'm finding that I'm probably the most annoying person on YouTube that I've ever heard. So I'm going to work on that. So listen, none of us are professional spokespeople here, so we're just doing our best to help everybody out and document what we do. So give us a break a little bit with our different regional dialects and our foibles. So anyway, getting back to this, trying to figure out a way, there I go again, trying to figure out a way to add some lugs to this bottom plate here. I have some of these terminal strips here, so what I'm going to do is I'm going to take apart some of these, particularly the center ones here with the post. If I take that off, give me a nice soldering point here to attach to these areas on the capacitor, and I think that'll work well. So let me start cleaning that up, and I'll show you what I'm talking about here. Move things into the garage here so I can utilize the vise here. I'm going to put this in the vise to hold this in place. I'm going to use the Dremel, I think, to clean off these surfaces here, and so we can solder those lugs directly on there. If I try to solder this right now, it's just not going to hold. So we want to prepare that. In the vise, something I've done here is, may seem obvious, but it's kind of a neat little trick, I think, that I found very useful. There's a couple little pads from Lowe's or Home Depot. Put that in your vise, and you have a nice soft grip. I'll be able to clamp that down without worrying about damaging it at all. So, whereas if I were to use the hard edge here, that could, this is fairly brittle, that's probably going to crack. Okay. Here we are in the vise, getting ready to be cleaned off with the Dremel. One thing you'll notice is right now it's very handy. We have a red dot here, red dot, black dot. We're going to lose that right now. So what I've gone and done is I've marked this. It's hard to see here, but there's a obviously black marker around the negative and red marker around here with the Sharpie. So once we clean off these edges here, the tips here, and polish it up, and we lose it, well, at least we'll still have our markings, which will come in handy later. Okay. You could just as easily use some sandpaper or maybe even a file to clean these off. The Dremel might be a little bit of overkill here. But I figured I'd give it a try. I've been, a lot of times I find myself doing things by hand. In the back of my mind, I'm thinking, I really should be using the Dremel for this, but I don't go through the effort of putting it together and giving it a try. So that's what I'm doing here. Use this this type of piece that comes with the kit. It's some type of sandpaper wrapped around it. Hopefully it's not going to be too rough on this. I'll go lightly and see what happens. I'll be back and show you what the results are. So we've got the first point dremeled off. It actually worked really well. I'm glad I'm using the Dremel for this. Took a little more effort than I thought it would to get a nice polish here, and so the Dremel's actually come in quite handy. I'm just going to rotate this around now and take care of these other two leads. Contact points, I should say. Alright, so I'm trying to harvest the center pin off of this terminal strip here. Here's one similar. So, obviously we want to take it off the board here because we just want the metal piece. I thought about drilling it out, but I didn't want to lose too much of the metal. So what I did is I used these very sharp pinchers here to sort of just crimp together the metal that is sort of splayed on the other end, keeping it together. That worked great. I just got under there, and as you can see, it's just dropped right out. So, okay, so I have one of these, and let's get two more. All right, so we have 3 of these lugs now. These will attach that way. Can you see that there? One of the things I'm going to do, I think I'm going to go back to the vise real quick and the Dremel. On these terminal lugs here, you can see that where there's sort of almost like a rivet point where they've pushed the metal through and used the little splays on the other end to hold it to the board. It's sticking out a little bit more than I'd like. I don't want, when we put this back together again, to have these this portion here rubbing against either the chassis or another wire or whatever. So I'm just going to go up to the garage real quick. I'm going to try to knock this down a little bit here. Not comfortable with that sticking out that way. Yeah, you gotta love that Dremel. Boy, that made quick work of this. Actually, I was surprised it took a little longer than I thought it would. Whereas if I tried to do this, with a file or maybe snipping it back, I think it wouldn't have come out quite as well. So again, I'm going to try to use the Dremel more often. It really does come in handy, even with this, fairly beefy. Where is it? Here it is. Bit here at the highest speed. I was on this for a good minute or so, knocking these down. So yeah, some of these, the metal was a little tougher than I thought it was going to be. All right, so that's all knocked down. I think that'll be fine. I didn't want to go too far with it. I could have really gotten it down, but again, I didn't want to lose too much of the metal and then have this sort of be brittle and break in half. So this is still nice and solid. And I think we've knocked down enough that's not going to make any contact with the chassis or the other leads themselves as well. Alrighty. Okay, we're using our crazy octopus arms here to hold everything in place. So I just got everything all held in place so we can get this all started up. So again, kind of like the tinning principle where you add a little solder to each piece that's going to be joined so that when to sort of aid the actual soldering when you put the two pieces together. You add a little solder to both sides. So what I've done here so far is I've added a little flux to each point that's going to be soldered together, and I'm going to add a drop of solder to each of these 3 points and to each of these 3 points, and then one by one we'll solder them together, and having that solder on there a little bit on each side, and the flux should help to make sure these go together really quite nicely. Okay, looking good. Really got a nice solder flow there. So when we join these pieces together, they should connect quite quickly. I can't emphasize enough the importance of having a good soldering iron for things like this, especially when you're talking about larger pieces of metal. A small standard watt iron is going to be fine for working on PC boards. You start working on these old radios, big pieces of metal that you're joining, point-to-point wiring, and then something like this. I've got for this, I've got sort of a medium-size tip on the iron and cranked up again to 899. If I tried to do this with a smaller standard iron, there's just no way that it's going to get hot enough for the metal to flow well. So do yourself a favor if you're trying to do this type of thing. Get yourself a good iron, and I can't recommend this Heiko enough. It's been phenomenal. Just made my life a lot easier. And this is kind of a luxurious item here. This heith desoldering iron. A bit of overkill for me, probably. Well, actually not. I mean, it really does make my life a lot easier when you need to remove solder. Much better than using the braids, etc., etc. So again, it was pricey, but it really does make a big difference when you're desoldering. So perhaps in future videos I can show you how well that works. Yeah, so that worked pretty well. Everything seems to have bonded quite nicely. You know, I've tested the strength on these; they don't seem to be going anywhere. So yeah, we got a nice bond there. So I think that was a pretty good solution. The orientation of these lugs may look a little strange. You may be wondering why I chose that. Well, I actually tried to duplicate where the old lugs were lifting up, so that when I pop this back into the chassis, the wires were sort of kind of fall into line. So I think this duplicates pretty well where the original lugs were on this capacitor. I probably could have done a better job putting these on straight, but I don't think there's going to be an issue here. Again, these are the two positive leads. These are going to be joined together. As long as we keep clearance from the negative, we should be fine. Let's put this back together again. I got to think about, actually, before we put it back together again, a way to test this capacitor to make sure that the lugs are connecting, etc., etc. Perhaps it's just going to be a basic continuity test, resistance test. I don't have a capacitor tester, so I can't really check that. So I might do a little research. I'm relatively new to this hobby. I know a bit about electronics, but I am not an expert by any means. So, you know, when it comes to, okay, how do you check this electrolytic and make sure that it's to spec, and you know, I understand the basics of continuity, etc., etc. But honestly, I'm still trying to grasp and get my head around what a capacitor does, what a capacitor does, and what it is. The concept of a resistor is so much more easy to understand. But you know, I'm getting there. Let me do a little research and see. And again, I might just put the basic do a basic resistance test, and I think that should tell me if making sure that we've got a connection between the lugs to the capacitor down here. That's probably going to be sufficient. Okay, yeah, based on some quick research, I don't really see a good way to, for me, given the equipment that I have right now, to actually check the capacitance here. There may be some ways to do it by energizing the capacitor, apparently, but I'm not sure if that's the case with an electrolytic or not. So actually, what we're really concerned about here is not the testing the capacitance here, because this is a new electrolytic. It, you know, it has virtually no shelf life. So, you know, I'm confident in the that the capacitor itself is fine. What we're really trying to check here is whether or not these contacts here are making proper contact with the electrolytic here. Now, you know, looking it over, everything looks fine, and there's every reason to suspect that we don't have an issue. But again, I don't want to put this back together and get it in circuit, and something's not working properly, and then for me to start questioning, okay, well, is something wrong in that can? That could really throw me off track and send me on a wild goose chase. So, so what I've done is you know, originally I had shown that I had this, you know, wrapped in electrical tape. I've removed that. This shriveled mess here has molted off the electrolytic, and let's just check the continuity, because really what I want to make sure is, you know, do we have connection from these points to those points? So I'll try to do this in left-handed as best I can here. So we're going to use our very basic multimeter here, and so I have it in a mode here where we're just checking for continuity and if we have a short. So what we should do is we should have a short between the two positives here and this positive terminal coming out of the capacitor here, and we should have a short, or you know, or connection, I should say. Short has sort of a negative connotation between the negative post here and the negative input of the, or I should say the connection point, the negative connection point to the capacitor. So when we start with that, we can just, I can see here, this is our negative. So we should have a short here. And you can hear by the sound that we do. And more importantly, we should have a short here after the soldering joint, right at this point, and we do. Okay, so not a problem there. And let's go and let's check the positive as well. Okay, and we're going to connect right here to the tip to make sure everything is good. Can you see that? Yeah. And we have a nice connection there. You can see it indicates a short. And just for the heck of it, let's check the other positive post as well. Okay, and yeah, all is good. So maybe a little bit of overkill testing this. It's relatively simple, but you know, always a good idea, I'd say. I should note too. I was saying that this is just one capacitor in the can. You know, others I've done have had. Well, I think the last one actually had 3 capacitors within the can, and you know, there's room in there to let me back off a little bit so you can see it. There's room in these cans to put up to, you know, usually 3 capacitors. So we would, you know, you would use the same principle we used here and the same procedure. You would probably do is you would join all the negative leads of your capacitors, because those are going to have a common point on the other side of the terminal as well. Anyway, so that's fine. So you link all those up. And no need to have, you know, 3 negatives coming out here. That's not how the way the original capacitor was designed anyway. And then you would feed your positive from each one down. And that can be a little tricky, you know, because you need to fit those 3 capacitors in there somehow. So you really have to think about how you know, the way you're stacking them, connecting them, etc., so that when you put it together, it's all going to fit. But you know, using the same principles, you would accomplish that. The other thing I just want to mention real quickly is, okay, well, you know, why are we doing this? Why are we rebuilding this can? Well, this radio goes back to, I'd have to double check, but I think it's a 39. You know, this is going on, what's almost 80 years now in age. And the electrolytics, as well as the paper capacitors, will fail on these over time. So I just I make it a habit to go in, and again, this is just from advice from many people much smarter than me that restore these things, to, you know, go ahead and just replace all the electrolytics and replace all the paper capacitors. Some people have different thoughts on that. They'll see what they can get away with, but they're going to fail eventually. So you might as well go ahead and replace them. This electrolytic actually had already been replaced by a previous owner of the radio. They elected not to use the can, however. So, oh, actually, no, I think on this one, how do they do it? I'm not certain. There was another smaller can where I know that that had been replaced, and they elected to bypass the can. I'm not sure if this one was still active or not. Again, I don't have the chassis right in front of me right now, and I don't really want to get into that. I just really want to focus on rebuilding the electrolytic in this video. But so obviously, when you start restoring these old radios, it's, you know, primarily what you're doing is you're replacing capacitors, and there are different types of capacitors. The ceramic capacitors and the mica ones generally don't need to be replaced. Okay. I think I'm going to, before putting this together, I'm going to quickly just polish this up a little bit. We may as well get rid of this banding here. I'm not sure what's going on there. I do want to be careful, however, to not remove any of the marking on this capacitor. I'd hate to lose that. Let me see what I can do to clean this up a bit. Perhaps a bit of metal polish where there's no markings, and maybe I'll use something a little more gentle here in this area. Might as well be easier to polish it up now without the lugs attached. No danger of damaging this, and certainly a lot easier than when it's hooked up to the chassis. You know, not everybody's going to be as finicky about the the appearance of the chassis. However, that's something that I kind of pride myself on, is cleaning these guys up. The chassis, the radio, the internals as well. I don't go to some of the lengths that some people do, where they actually de-rust and bathe these things in baths for days and days to really get down to removing all the rust, etc., and priming, etc. It's probably a good way to go, though, if you really had a severely rusted chassis, because that rust is probably to come back. I haven't encountered a chassis that bad yet, so I'm not even sure I would tackle something that required that much work. But I've had a fair amount of light rusting on the chassis, and I usually make a good effort to polish that up. Usually it's just dirt and debris. I had one radio that I worked on that was clearly owned by a smoker, and the tar and tobacco residue was astonishing, really, and the before and after that was rather striking. That was a dirty job, but somebody had to do it. All right, let me polish this can up, and I'll get back and show you if I had any success with that. Okay, pretty good. That's my bad Larry David impression. Yeah, looks good. A little bit of Simichrome, and this stuff is great. This Meguiar Scratch X 2.0. Great for Bakelite, great for aluminum, great for plastic. It's just a phenomenal product. May not remove some of the deeper scratches and things, but it's certainly, if you want to use something that removes the deeper scratches, like the Novus, is the Novus 3, whatever the stronger Novus is, you can use that. But that'll leave some swirling, and then the Scratch X will remove those swirls to give you a nice smooth surface. I've never had this Scratch X actually ever create scratches. It's great at removing them. So I was just noticing here on the markings on this that indicates that this is a dry electrolytic capacitor. I've never heard that term before. Perhaps because this was newer technology when this radio came out in the late 30s. Just did a quick search here on the sciencedictionary.org here, and it says, what is a dry electrolytic capacitor? I imagine that most modern electrolytics would fall into this category, but I'm not certain. But it says a dry is one in which the negative pole takes the form of a sticky paste, which is sufficiently conducting to maintain a gas and oxide film on the positive aluminum electrode. Okay. Again, so I don't think it's completely dry. I think the paste would have some liquid in it as well. And then so it begs the question, okay, well, what's a wet electrolytic capacitor? And we have here, what is a wet electrolytic capacitor? And that states one in which the negative electrode is a solution of salts, example being aluminum borate, which is suitable for maintaining the aluminum oxide film without spurious corrosion. Okay, well, there you go. Apparently what we have here is a dry electrolytic capacitor. All right, all polished up. Let's put it back together. So here's the chassis that this capacitor goes with. It's an old Zenith here. The reason why, well, let me just show you a little bit first before I tell you the reason why I brought it out. This is another capacitor here, electrolytic. I just want to show you real quick on top. That's another aluminum can. This is the one I was referring to earlier. It's a quite tall, narrow one. I've never seen one quite like that. Most of the radios I've done so far have been from the 40s and the 50s. This is the first one that goes back to the 30s, so things are a little bit different. That one has been replaced with this 12 millifarad capacitor. So, I may elect to do the same thing here, and just, as you can see, the old one's been cut out of circuit. I may elect to get rid of this here and rebuild this one as well, or this is actually pretty clean the way they've done it, so I may just take this one out and replace it. The one we're working on now, the 16 with the 2 8s in it, I don't see that jumped anywhere. Well, actually, no, it wasn't, because these leads were actually in place, which I cut from, so that was being used. Whether this capacitor was a replacement or not, I'm not certain. Theoretically, it could have been replaced at some point as well. When this one was done, they just may have elected to use a can instead. I think it's original though, because I believe in the schematic that I have, it refers to a 8/8 electrolytic with 2 8s in the can. So I think if somebody were to replace it, it'd be unlikely that they would put another 8 in there. Maybe, but unlikely. Anyway, let me just let me put this over and tell you the reason why I got this out before I put it back together again. Let me just try to do this. If I can get this flipped over here. On the chassis, you can see this still has quite a bit of cleaning left to do, and these capacitors, all these old wax and paper ones, are going to be replaced as well. So I really haven't done much work on this yet. I have elected to protect the dial here. Something I tend to do too is I create little panels to either protect the speaker or the dial. This is actually not a speaker, this is the dial. The speaker in this is separate, so that was taken out, and I also put a protective piece of board over that as well, just to protect it while it's in storage. Since we're here, I can just show you just some spaces here to protect the dial underneath, and tied together quickly with some zip ties. Anyway, getting back to this electrolytic, the reason why I took it out before I put it back together again is, I'd kind of like to orient this in a way that we're going to be able to see the markings on this. For one, I think it's interesting, and two, I think it, who knows, this radio could still be in use 50 years from now, somebody like me in the future could be working on this and looking to test things out and keep this radio in action. So just as a service to them, I think it would be nice to be able to orient this so they can read the markings easily. I think the best way to do that is there'll be a tube here. Of course, you could pull that tube out. That's going to go here to read it. So it could, theoretically, the markings could go that way. And the same goes for this way. I think what I'll do is I'm going to put it in sort of like this. I'm going to orient this unit inside so that the can be oriented in this direction. So you might have a kind of a diagonal window in here just to be able to read what's going on here. So, and the way to do that is, if you can see down in there, you can see the leads. The two here on the right are the positive leads, and the one on the left is the negative. So I'm just going to put this back together again so that we plop this in and strap it down with this clamp harness here, that we'll be able to read it. I'd hate to have it put together and have the markings go that way. Little things, folks. I just I laid the can in there quickly, sort of dry fit, and I marked a little line here where the negative terminal should go. So you can see along that line I've aligned the negative, and the two positives will fall nicely there. So I'm going to start now folding this back here and see if I can get this to sit in there nicely. If I can't fold it back well, it looks a little bit ragged, one trick we can do is we can use a sort of a pipe clamp, and we'll go from there. So I think I have one that'll fit this size. Let me see what I can do folding it down, and then we'll go from there. Yeah, so instead of I don't know, sort of working at this with pliers or a blade, excuse me, I went right to the pipe clamp. You can see how I have it fitted here. What's happening is I tighten it, and again, I kind of just got it over this lip here. I don't want to be squeezing down this part of the body. It's kind of interesting. There's sort of a high point here where the band starts coiling back around, and you can see that that high point around the rest of the band, it's not really doing much to push that lip back into place, but the high point is pushing down. So what I'm going to do is I'm going to sort of tighten and untighten and rotate this and go around. I'm going to sort of let this high point push down the circumference of this lip. Let's see if we have good luck with that. And all the while, I want to make sure that the other sides don't pop up. So let me see how that works. Just working my way around. Seems to be working well. Actually, this technique seems to be working best. Just sort of, again, using this high point here on the clamp and going at it at an angle. So I'm just trying to push that most upper portion of the aluminum to bend over back down. So I'm just going to keep working my way around and sort of push that lip down in this manner, going low here, a little higher there, and again trying to push this this upper portion back down. It seems to be working well. So let me go around the whole thing and see how that turns out. Working along with the pipe clamp worked pretty darn well. Got it mostly in place. So now that it's at this state, I'm just going to use the blade of the screwdriver here to sort of push down a little bit. I started that here, and you can see how nice and clean that looks. So let me just go around here with the blade, push the remaining this down, and show you what it looks like. Did mar the surface of the aluminum a little bit here. Not a big deal. I could try to buff that out, or perhaps it would have been better if I had put some protective tape around here. Live and learn, I guess. Well, here we have our rebuilt Electrolytic. So I finished going around the edge here with the blade of the screwdriver. That looked great. I did introduce some scratches here by using the clamp. I buffed that out a little bit using the Novus that I referred to earlier, the Novus 3. Here, let me show you what that looks like. Yeah, this is intended for plastic, but it's it works for metal too. It's got a bit of an abrasive component to it. There's also the Novus 2, which actually the Novus 2 I don't find works very well. That's sort of a mid. I think a good substitute is and this is for all uses, plastic, Bakelite, whatever, for the Novus 2. I think works much better as this Meguiar's Scratch X2. But the Novus 3 I like quite a bit for removing large scratches. It turns out it works pretty darn good on metal as well. The Novus 1 is a spray, which is sort of kind of nice. It helps you clean up any mess left over from these products and puts a little bit of a shine on it. That product is fine too, but again, I don't really recommend the Novus 2. It doesn't work well for me. Tends to introduce scratches when I use it, and then there's no way using the Novus products to remove those fine scratches. So that's just been my experience. So anyway, we did that. Polished it up a little bit, remove those most of the scratches, and just went over and just tried to get this back looking the way it was. I used a black Sharpie here to denote the black negative lead. And a bit of Tester's paint here, enamel paint. This is basically a marker, and but it's a marker, but it's actual enamel paint that comes through the marker. So dab that on there, so it looks sort of like the original, and that's about it. This wraps up the rebuild of the Electrolytic video. Again, my first video. Too many ums. I apologize. I don't know if that's gonna get any better. Let's see if this turns into more videos from me. I have maybe we'll take through this old Zenith here. Maybe I'll document that as we go. I'm not an expert in electronics. I know a fair amount. I learned a lot from a lot of YouTubers out there, and there's some great ones out there. Some YouTubers that really know their stuff. But I've managed to do a pretty good job of restoring a few radios thus far, replacing the capacitors and using different things like isolation amplifiers and dim bulb testers, which I've used, and purchasing RF signal generator here and VTVM as well. So these are things that I'm fairly proficient in using now, and so I'm able to do a lot of this work pretty well. Still trying to understand, really nail down the basics, principles of the circuits in the radios. I have a pretty good understanding now of how the RF works and the different IF stages. I understand the principles of the super heterodyne. I understand what a capacitor does. I understand what the transformer does. I understand the IF coils. It's just really understanding how all these circuits come together fully and how to sort of test the circuit and be able to diagnose issues by checking voltages, etc., etc. So this is something I'm working on. I've been reading extensively different books and things, so I really want to be able to understand these circuits even more thoroughly than I do now. So that's going to be kind of a learning experience for me as we go. But so far I've managed to restore a few radios, got them back into great operating condition, and you know what? Most importantly, I have not electrocuted myself, so that's a big, big plus. All right, thanks for listening.